Hello and welcome to the Smooth Scaling podcast, where we talk with industry experts to uncover how to design, build and run scalable and resilient systems. I'm your host, José Quaresma, and today we had a really insightful conversation with Moji Sarooghi, a very dear colleague and a distinguished product architect here at actually our first returning guest. And today we discussed in detail our virtual waiting room, how it looks like from the visitor perspective, so how does the journey look like, but also how it looks like behind the scenes, what are the services and technologies powering the waiting room and our system, and also what makes Moji excited about for the future, what are the things that him and the team are looking forward to improve and set up in the future. Enjoy! Welcome, Moji. Actually, welcome back to the podcast. You're our first repeating guest.
Okay, nice to be here, and it was good to be here before as well. So
hopefully it will be good as well today.
Yes, thank you.
So today we're hoping to get a little bit more into the details of how a virtual waiting room and our virtual waiting room works. And I would like to start with asking you kind of maybe some of the basic stuff. So when a visitor is kind of trying to access and going through the waiting room for a protected website, kind of what is the flow?
The whole flow from the visitor perspective is that the visitor tries to buy something from a customer website. It's protected by or what we call it a connector. And what is this? Actually, is a piece of code that run based on the scenario on the edge or on the customer website. It really depends on what is the setup there. This piece of code will intercept the request, and based on the information and based on the context of the request, we make a decision to redirect user to the waiting room or not. This is more like, I talk a little bit on the technical part, but from the visitor perspective, he goes to the website and then he sees that there is a waiting room, and he gets a lot of information about where is his place on the waiting room, what he is expecting to be, what he's expecting to be happening in a couple of minutes for him. So we are proud to say that we have a good user experience, fair and informative, so the user can see what is going to happen from the user side and from the user experience side and from the technical side. That we are proud to say that we have a lot of connector that can be integrated by the customer pretty fast. We call it instant connector integration. And I think that is one of the really interesting things at Qt, what we offer.
Awesome. And on that connector side, I think you mentioned Edge and you mentioned kind of in the customer website. Can you tell us a little bit what are kind of the main differences? Yeah.
Sure. I remember actually when we started to move more toward the edge, what we did is that we had this integration on the server side. I think one of the first one was C#. So we had a piece of code customer would put on their server, and then they would integrate with us on their server. And then 6-7 years ago was the time that different technologies like CloudFront, Edge Workers, it's called Lambda on the Edge, and all the other providers, CDN provider offered this kind of compute on the edge. And we thought, pretty cool. We can start leveraging this technology to make it easy for our customer to integrate with us. It's good for them and it's good for us. Why it's good for us is that the maintainability is pretty easier. So we have different customers, all they use the same technology to integrate. And also it's pretty important here, the whole integration will happen on the edge, means that the traffic flow, if there is an increase of the traffic, it does not affect the server of the customer. It will be intercepted on the edge, closer to the visitors. So performance benefits. The other part which I really like it is that how easy make it to integrate. Imagine you have a really old web server that has a really old code, and then you want to integrate it on the server side. If you do it, it means that you need to involve a lot of development team. What should happen? There is this Java server. Do I need to use or C# server? Do I need to use the actions, filters, or do I need to use a middleware? But on the edge, you don't touch anything on your server side, and then you put Qt code on the edge, and then everything will work for you. When we say it on the edge, it's if we want to talk a little bit, in the technical terms here, is that the CDN previously did not have the capability to run the compute. However, now I mean last couple of years, they have this capability. So means that there is a proxy on the server that you can execute the code, and it's exactly the place that we run lightweight Qt connector at the edge.
Nice. I mean, it makes total sense with the edge side from a performance, from a, I guess, as you mentioned, simplicity, right?
Exactly.
So you also have less, I guess, variation, that you're not dependent on the existing architecture on the server side, right? So it's you keep it much more clean and separate.
100%, yeah. There is all those stuff related to security, performance, closer to the end user, all those stuff one side, the technical, also the maintainability. I remember some of the customers, they had, I don't know, thousands of developers who created their websites, not exaggerating, but there is a lot of team involved to produce their product that had shop, that had the different part of the web pages. So getting hold of those people to be able to create a solution on their server is pretty hard. And if something happens and you want to help them, it's pretty hard. But when we say on the edge, is that we are totally decoupled from their technology and from their development style even.
Yeah. And I would say a kind of a part of an important component of this journey is that we also have confidence that users cannot bypass the queue, right? So how do we look at that, right? So how do we enforce that the queue cannot be bypassed?
Yeah, I don't want to go too much detail on that one.
That's fair. Yeah.
But what we are talking about here at Qt, we have, how when we started to develop the connector, we had this client-side integration, and it was, what we were doing is that we were looking at the using the JavaScript on the client side to be able to understand if user has passed the queue or not. That was easy to bypass. And when you search on the internet how bypass Qt, usually people see some articles and then some customer says, oh, we can't bypass, and we say no. This is a different integration that we are discussing about here, and that is the main one that we are promoting server side. How we do this one, we use all the different hashing and different verification on the request, that is this request has been through the queue or through the waiting room or not before. And if it has not been through the waiting room, should it go to the waiting room or not? Based on that kind of like a condition, we can we will let the request go to the origin, or we will redirect to the waiting room. And we know about the bots. There is different kind of you guys have done quite a lot of podcasts about the bot protection at Qt, how we try to help on that one. And we know that the market try to bypass us pretty aggressively. But also we have a lot of different level of protection, and based on the scenario, we can enable it. One of the first and basic one we say is the server-side protection, which the code cannot be manipulated, and request context will be intercepted on the server side instead of the client side.
And I think when you're now saying server side, you're including both what we talked about as the server, kind of the connecting server, but also edge. So the edge connectors, you're also putting them in that
100%. Yeah. When in the broader perspective, when we say connector, we say the connector that does their task of verification user on the client side, and the connector that on the server side. And then when we move on the server side, is that where do you place that code? Do you put it on the edge, on the proxy level, or no? Do you put it closer to the origin, which is the server?
Got it. And I think maybe just to add there on the thing, quite something that we also see sometimes kind of with the solution architects and in the team, is that sometimes the bypassing could also be not necessarily not a vulnerability in the system, but just that when you then kind of design the user journey and say, okay, there's these 2 entry points to the part that I want to protect, and you protect those entry points, but then you actually forgot the 3rd entry point, right? So in that sense, the ones that were set to be protected are being protected, but then the system could be bypassed if users can go through a 3rd entry point that is not being protected by the queue, right? So that's kind of a bypass of the design as a whole, but not a bypassing of the system itself from a vulnerability
100%.
perspective,
Yeah.
right?
It means what you are referring to, and you know better than me that it's how we set up. That is part of this story as well. Yeah, you have a technical limitation. You have maybe you have a vulnerability. I don't know what, but also you have something related to the setup that we see quite common, and also that is part of our job as well to guide our customer to the right direction. And again, there is all the different. Sometimes you see on the Twitter there is something, or on the Reddit it's something. But then, you go and investigate and say, oh, there was a misconfiguration here. Oh, this kind of protection needs another level for this specific use case. So the base is there. The base is that needs to happen, not on the client, on the server side. The second part is that we need to do a good setup, the kind of like how we plan this one. And the third one is that do we need a customization? And we are good at that one. I think that we are pretty good. We have a pretty strong team on the setup and also customization based on the needs of the specific customer.
Nice. So I think we have been talking about waiting room, but we also have this the peak protection mode, right? So that users could also be kind of accessing a website, but there's no active waiting room, and then it's up to the system to decide and evaluate, should I be forwarding users to a waiting room, or should I just let them through to the website, right? So can you tell us a little bit about how that part works? How is that decision made?
We call this feature safety net. It means that it works as a safety net. It means that, again, in the part of the world, you don't expect the traffic happen. You don't have a drop. You say, okay, it's my normal business days and everything is working. And in the normal business day, I can have thousands of visitor per minute visiting my website. You can do a calculation. What does it mean based on the request? What does it mean based on the session? And then you will end up that number. You come you do a setup on your at Qt on our Go platform, and you say that, okay, this is what I can handle. And then this will work on the background. And what does it mean is that connector will do its logic or do its magic to understand how many requests, how many active visitors you have. And based on the setup, if there is a spike in the peaks, why that can happen, I don't know. Suddenly there is a post on the social network that marketing wanted to promote a specific product, and there is a peak of visitor coming to the website. Then the queue will be activated automatically. So in this scenario, what our customer is that it's like an insurance. Yeah, we like to use the insurance for that one. You are in control of your traffic. If something unexpected happens, and we have quite a lot of our customers, specifically in the retail market that use this feature, and also I see
financial services as well.
Exactly, and also I see more interest also in the airlines and those kind of markets that there is some stuff happening without people being notified totally.
And you as a customer, you can also kind of have a setup that has both, right? So in a way that you could have in your website, if you're doing a drop for a specific product there, you could have a schedule waiting room. That's the other part, the other one that we were also talking about in the beginning, right? A waiting room that will always show, be visible and you're expecting that product to drop and to start the sale at 10 a.m. But then you can still have the 24/7 peak protection, also known as safety net, on the whole site as well, right? Or it's very kind of, you can configure it pretty fine grained on how you want to queue people and where and when.
Yeah, that's really cool. Yeah. Qt solution is pretty flexible from that perspective, and we have been running this. We have been in this business last 15 years, I think. And then we have seen quite a lot of different cases. I remember a specific one that this setup that you are mentioning was discussed pretty heavily. And the scenario was that the customer had a specific drop on a specific path of the website. Yeah. Imagine that you are selling a specific product and it's / product XYZ. But then they were worried that if when this comes into the picture, not people just only go to that specific page, but they go in all the other part of the website. Yeah. So what they did is that they put a pretty low, but they put some kind of outflow, we say, for that specific path. And then they did a schedule waiting room, and then they created a safety net or 24/7 peak protection on the whole websites, so they could kind of like manage if peak of visitor, just because they don't know where they should go, they go to the main website, they can protect that website crashes or disturbance work. Yeah,
that makes sense. Thanks. And I think when I think about kind of what we do and with the waiting, I think there's a couple of things that at first look pretty simple, but then when you get to make them work at scale, I think things get pretty complicated, and I think it's quite impressive that we managed to do that at scale, right? And so I wanted to just touch on the two of them. So one of them is the first in, first out principle, right? That's one that, I mean, if you're writing down an algorithm at home, I don't know how many do that, but if you're doing that for a small scale kind of thing, okay, this person comes in, I put them in the end of the queue. This one comes in, I put them in the end, right? And then you take it through. That's pretty easy to have a very simple approach, but then I think it's super complex to do it at scale in the thousands and millions, right? So can you tell us a little bit about how we make that work?
Yeah, the whole art here is that we are talking about the traffic per minute, couple of millions, yeah? Couple of 10 millions. And we are saying that, the stuff that is a DDoS attack for some other businesses, for us is a daily business. So the system that we design is not just about first in, first out. It means that it's a distributed system. It can scale pretty fast. It's fault tolerant. At the same time, it is doing that first in, first out. And when you put all the stuff together, not mentioning also a good user experience, informative. So when you put all the stuff together, it just makes it a little bit more complicated as a whole. But then I think I talked quite a lot in the previous episode about the simplicity. We try to achieve this stuff by creating simple kind of like services to create this whole complicated system out of it.
Yeah. And you mentioned the thing, I think you said information. I think another part that I mentioned two things. So the first in, first out part, but then also the expected waiting time, right? That's also one that I think if you think about it at a very small scale, it's pretty easy. If you have 10 people in the queue and you have one per minute coming out, you kind of know how long it is for the 10th to wait, right? But when, again, back to a distributed system and making that work at that scale is quite impressive.
Yeah, that's you have a point on that one. And the main thing here is that the distributed system, which can scale, and one node can go down or a new node can come up. How you do a database lookup, how many times per second you do the database lookup, how do you do your caching system, and then do you do the lookup if, for example, some information is in the cache, how much the TTL the cache has, what kind of a database you use. I think I could say here is that one part of our system, if I want to be really technically in depth here talking about that, we are using DynamoDB in AWS. And it is a pretty neat technology. It can handle couple of 100,000 per second TPS distributed requests, and it can escape pretty good. And that is still one of the main technology that help us to achieve this one. Beside all the other auto scaling and stuff and design, but also having this kind of like a technology is pretty helpful on that picture.
You mentioned the kind of that for we handle the amounts of traffic that for some people, some customers out there is technically a DDoS for them, that we handle that every day, right? So how can you share a little bit on what is it that kind of from a design perspective, from architecture, how can we handle that, right? So what have we done? What do we have in place that allows us to be able to handle that volume?
I think, again, I go back to that one. I think the first rule is that create your system simple. If you cannot call somewhere else out of the box that is executing a logic, don't do that one. Don't try to create a complicated architecture that you call one node and the other node call the other nodes. I'm not, I don't want to enter the fight between coupling and cohesion and whole microservices, but having in mind that your system needs to be simple will help quite a lot. And the whole design for failure part, that was also another episode that one of my colleagues actually did. It's pretty cool. Motto in this designing this kind of system and using the technology when it's needed. Not just because there is a tool or I don't know SNS in AWS, I need to use that one because it looks good. No, that will not do that one. And then also I would say kind of like a layered system in a way that the layers are needed. Like we are using also WAF in AWS. That is part of whenever we need that one. But at the same time, we have our own kind of like a protection related to the how many requests we get. And then you have all this scalability and being stateless. There is all this different factor in the design. I will go first. I would say that my answer on this one is that simplicity and having the design that you are creating a system that needs to be available 24/7. I didn't talk about this, but I think this is also one of the most important part of what we offer to our customers. We have a system that is reliable, and usually when in the development team, in the product team, whenever we talk, we say that first thing first, system needs to be available 24/7. And that is and reliable. Availability and reliability, the first one. And then to achieve that one, you put this one and print it, put it on the wall. And then you say, to achieve this one, let's find some kind of tactics, strategies, do a simple design, create it in a way that it can handle it can handle overloads, fallbacks, think about the failures, and put the technology that it's needed to handle the stuff without trying to complicating the solution. I don't know how much I answered your question.
No, I think that was a good answer. Thank you. And so now, I guess from a user journey perspective, we talked a little bit about or visitor journey, right? That kind of trying to access the website, being redirected to the waiting room, and then they are there in the waiting room waiting. And we talked a little bit about that, about the kind of the importance of using kind of queuing psychology and providing as much information as possible to the visitors that are waiting. But at a certain point, they will then be redirected to the website, right? Can you tell us a bit more about that part? So one of the things being how to determine the ideal flow. So that's what we usually call outflow, right? So that's outflow from the queuing perspective, right? So what is the outflow from the queue, the waiting room, to the website, right? So I guess there's two questions there. One is, how do we determine that? And then second, how do we enforce that? Again, back to the pretty easy to design a super simple system that enforces that. In a multi-server distributed system gets much more complicated.
Yes. From the informative part, and user experience and user flow, as we discussed, user knows that he wants to buy this specific product that is pretty, hype. he or she or go there and then get redirected to the waiting room. We have this, and again, this is something that we are proud of, is this custom team that you design your waiting room with your brand, with all the information. You say sorry or not sorry. We are happy that having you here. You are seeing this page because you are waiting for this specific product, and then this is something static. As a customer, you design your system, and then we add some dynamic information to this one. What is your expected wait time? When how many people are in front of you? People can add some information. We say that messaging, and we usually tell our customer that put the good informative messaging, say to the people that don't worry, we have stuff in our stock. There is a stuff there, so you will get to what you want. If you didn't, then we have other way to reach to you. So this is the whole good user experience. Again, I mentioned the static part, kind of halfly dynamic part that customer brings and add messages, and totally dynamic part related to the how waiting room is reacting, like a wait place in the waiting room, the wait time, and all those stuff with the cool design, with the color and stuff like that. This is on the user side. On the backend, what we do is that this distributed system, every one of the server, by sharing a message, you could say in some part, using a kind of like a database, using cache, they communicate together in different with the different technologies. I can say we are using in some state, we are using a database pretty fast, like Dynamo one, to be able to this different nodes of the you could say that the flow managers, waiting room flow managers, communicate to each other. They would report that I have received this number of requests in the last minute, and then or last 10 second or last second, and then how much is the setup for the outflow. Then when all the nodes get this information, they make a decision what should happen in the next 10 seconds, how many they should redirect. And there is a lot of interesting stuff in these challenges. What we call it as a no-show is that there might be, for any reason, that when we want to redirect the visitor is not there. Maybe he changed his tab and looking at something else. At the same time, we want to get the flow back to the origin. We don't want to make people wait if more than what is needed. So if the customer says that my outflow is 500 per minute, I can handle that one. And in my system, we try to keep 500 per minute. So the server needs to react based on the request that they get from the client side. They talk to each other and make a decision. Okay, I want to redirect this specific people, number of people. We have some cool name. We call it open window, which means that what queue numbers are allowed to get redirected in the next 10 second or whatever is that interval. And then the server, they talk how they I know that one part of a system talk why this NoSQL Dynamo. The other part of a system, they can send a message together and make that decision that what it should be redirected. And this should happen pretty fast. We are talking about seconds and minutes in this scenario, in a reliable way as well.
And so when the user is redirected, how do we then how do we pass on that information? So we have something, the Qubit token. So is that can you tell us a little bit about
Yeah. In this scenario, what we do is that we put some information. We use the internet technology. This is not anything hidden. User or visitor get redirected to the queue by a 302, and then they will carry what kind of waiting room they want to see. And when it's their turn, we will carry back what was their QID, and then also the time of a redirect and some other information. And we do a hashing of that information. So our connector, one of the things that our connector can make sure that request has passed or visitor has passed the waiting room. Is this queued, we call it queued token, that is hashed. In that information, we can add all the different information, related to that visitor, so we can recognize this visitor was the one that has been waiting on the waiting room. So we have different tooling for that to make sure that the person that started the journey is the person that lands in the connector, and the connector verify that's one. And it could be stateful or stateless, that server can verify its or connector can verify it on the edge or on the origin based on the setup, or it can communicate to us and say that in the more stateful manner, that was it the same visitor or not, and what was the experience when he got to the waiting room and when he or she got redirected back. So in a short, we have a static verification and also dynamic verification of this visitor doing the whole journey.
And then there's, I guess, one step further is that the user does get a cookie that keeps on using further onwards, right?
Exactly. Yeah. In kind of like a simple way, as a visitor, you get a ticket. That ticket will be verified by. At the queued site, you get a ticket. The ticket will be redirected to the connector. Connector will verify that ticket static way and dynamic way based on the scenario.
Nice. Thank you. I think it was a good overview. Is there anything you would like to add from kind of when we look at kind of the visitor journey, and was there any question that I forgot to ask?
No, I think actually we covered quite a lot. Yeah, we went through the whole user experience, whole integration part, and little bit touching on the development of the technology and at least some kind of practices, architectural practices that we have. Again, I talk about that one. I think it's still, not started in the middle. I mentioned that one, the reliability. That is what we promise and what we keep in mind when we design the system.
So Moji, now I would just like to ask something kind of, I think as I said, it was a really kind of good overview. Can we talk a little bit about, I don't know, it could be a bit random, but can you share with us some of the specific services that we're using on AWS and kind of why and how do we put them together? I mean, I know it will take forever to go through all of them, but what are the kind of the main things that come to mind?
Sure. From the AWS perspective, just if I want to just name technologies that we use application load balancer. We use EC2 instances as a compute. We use ECS as a kind of like a Kubernetes or Fargate, you would say there, container hosting orchestration. We use SQS, we use SNS, and I said the main important one that I really personally have a good kind of like I really like it, that is the DynamoDB heavily. Then we are using the Edge, CDN, CloudFront. We use Lambdas. Also, we have a connector on the Lambda Edge. It's not part of the heart of the queue engine, but as a connector, we do that one. Actually, I think it was our first Edge connector, or no, I don't remember. But it was something that existed back then. We use WAF technology, which is at AWS. What else we use? And we are using all the different stuff related to, permissions and all the compliance, and also, Athena, all the different kind of technology. But there is main thing here is that, again, use the technology that you need in a way that you want to achieve what you want. So is that when I want, or when I am called to a meeting, I don't say that, oh, did we use this technology, or did we connected this Lambda to that technology or not? We say that what we want to achieve, and then go and pick what help us to achieve that one. So we do it, I think we do it in a right way. We start by the what we need to solve, and then find tool from the AWS toolbox to solve that one.
And so And looking forward a little bit, is there kind of, I don't know if I would guess that there's a lot of stuff on your mind all the time, but is there a couple of things that kind of are more kind of highlighted in your mind when thinking about the future, the next few years that you are considering?
Yeah, I think we are pretty excited and working on this cloud agnostic or multi-cloud solution. This is getting a really hot topic, and based on all the compliance, all the different kind of like a cloud provider, how we can design a system that is portable and hold this Kubernetes help us to do that. But then there is all the different tooling that we have out of the box in AWS, and how we can create a system that can be a plug and play. You go and plug the new tool and it works. That is one part. Also the tool choosing as well. Is it open source? Is it kind of like is it managed, unmanaged? There is a lot of discussion there, but it has a really nice challenges out there. I think we will talk later on of the challenges. I know also one of my colleagues have talked, but those challenges of going from managed to unmanaged to open source is pretty interesting. That is one part. We have recently, I think we are finalizing now. I don't know if we are in GA already or soon, is that bring your own proxy at Qt. Means that our customer are able to set up their proxy in front of waiting room. I really like this kind of feature that we have here. We give our customer a bigger we give them flexibility to, they also have some kind of the traffic goes through their proxy before hitting us, and it gives quite a lot of potential. And I know we already talked about HEP in one of our podcasts, and that is one of the things that our customer will be able to do. That means that they can put their own specific bot protection tool in front of Qt's waiting room. So whatever tool that they use for the user journey, also they can apply that one when visitor goes to the queue, which is pretty cool. I'm really proud of this kind of like a release. Also, we are thinking more and more. It's again, we are talking about North Style and kind of doing a research how much we can leverage more on the edge related to the Q core, not just the connector. And this, I think this is also something interesting will be out of that as well.
Exciting. Maybe I'm sure we'll have you on the podcast again, maybe then whenever we get to that decision and maybe past that project, then it would be great to hear some more about it.
I will be happy.
I think we covered a lot. We went through the journey. We got a little bit into the nitty-gritty and got some details out of you and some thoughts and considerations as well. So I think it's a good place to wrap it up. Thanks so much for coming by.
Thank you for your time and happy to be here, as always.
Thank you. And that's it for this episode of the Smooth Scaling Podcast. Thank you so much for listening. If you enjoyed, consider subscribing and perhaps share it with a friend or colleague. If you want to share any thoughts or comments with us, send them to smoothscaling@qit.com. This podcast is researched by Joseph Thwaites, produced by Perseo Mandilo, and brought to you by Qit, your virtual waiting room partner. I'm your host, José Quaresma. Until next time, keep it smooth, keep it scalable.